Hey guys, it's been a while. Hope everybody had a relaxing spring break and you're ready to get back into it. Um, as always, when you are done scoring your work using this video, could you please pop onto Google Classroom and just leave a comment on this assignment so I know how you did on this, okay? So here we are, number 5. We have a function and our first task is to find the average rate of change between 0 and pi. Now don't get these two concepts mixed up. Average rate of change versus average value. If I'm just using, this isn't f of x, but if I use this as an example, the average value between 0 and 2 pi would be that technique where we integrate over the whole interval and then we divide by the length of the interval. Kind of like you're finding the area of a rectangle and setting it equal to the area under that curve. That's not what we're doing. That would be finding the average value. That would be integrating from 0 to 2 pi and then dividing by 2 pi. You're finding the average rate of change between 0 and 2 pi, and that's just as simple as finding the slope between the endpoints. Well, I guess, I'm sorry, I'm just making up an example between 0 and 2 pi here. In the actual problem, we're going from 0 to pi on this function. I'm just using this graph as an illustration here. So the average rate of change is the slope between 2 points. Just like the instantaneous rate of change, we get that from the slope, the one slope at a single point. The average rate of change would be the slope between 2 points. So that's what we're going to do. Okay. The average rate of change between 0 and pi is going to be this value right here. And in order to find that, I found the actual endpoint. So my interval is 0 to pi. So the actual endpoints are 0, 1, and pi, negative e to the pi. Just plug 0 in and get its y-coordinate, plug pi in to f and get its y-coordinate, and then find the slope between those endpoints. Any version of this is fine. If you use the negative up here and distribute it through, any equivalent answer is perfectly acceptable. So out of 9 points for this whole question, part A was worth 1. 1 point if you have any version of this correct answer, okay? Number 2, what is the slope of the line tangent to the graph of f at 3 pi over 2? That's basic skills. You're going to find f prime, you're going to plug in 3 pi over 2. I'm hoping everybody got this. This is going to be worth 2 points. 1 point for correctly identifying f prime, and another point for plugging in 3 pi over 2 and getting this answer. So given f, we just use the product rule to get f prime. Now I factored an e to the x out. You don't need to do that. Any version of f prime is fine as long as it is equivalent to this. I factored the e to the x out, and then I switched the negative sign and cosine so that it looked like this. This is a nice version of the derivative. So 1 point if you have any version, anything equivalent to this for the derivative. A second point for actually plugging in 3 pi over 2 and getting e to the 3 pi over 2. Cool. Part C is finding the absolute min between 0 and 2 pi, and this is the kicker here. You got to be able to justify your answer. So I think we've done this problem enough times that you realize you're going to have to do the candidate test. The first point you're going to get is for identifying that you are supposed to set f prime equal to 0. Now I didn't act f prime, I had, oh, there it is right here. So I have f prime here, I'm just referencing it. So I'm just going to say f prime equals 0 means e to the x either equals 0 or cosine minus sine equals 0. This doesn't produce any answers because 2.7 to nothing would ever give me 0. Cosine minus sine equals 0. If I just add sine to both sides, cosine and sine are the same thing, add pi over 4 and 5 pi over 4. So you've got 2 points so far. 1 for identifying that you are supposed to be setting f prime equal to 0 to find your critical numbers. and a second point for identifying pi over 4 and 5 pi over 4 as your actual critical numbers, as candidates for the minimum. The third point you may have, but you are only allowed to give yourself this point if this number is backed up by this entire table. The absolute min is negative root 2 over 2 times e to the 5 pi over 4. Man, that's a messy number. But it's definitely the min, and it happens at x equals 5 pi over 4. We can only accept that as a justified answer if we actually performed the entire candidates test, which means you needed to set up a table that included all the candidates, meaning the critical numbers pi over 4 and 5 pi over 4, as well as the endpoints 0 and 2 pi. And then carefully plug all 4 of them into the original function f. So be sure you're labeling your table here. Here are your 4 x values. Here are your 4 f of x values. Plugging 0 in is easy enough. I just get 1. Plugging in pi over 4 gives me, I don't know, I was going to try to estimate these, but it turned out I didn't really need to. I'll come back to that in a second. E to the pi over 4 times root 2 over 2. Whatever the heck that is. Plugging in 5 pi over 4 gives me e to the 5 pi over 4 times a negative number, negative root 2 over 2. And then plugging in 2 pi gives me e to the 2 pi times 1, which I'm assuming is going to be my max. But this is, we're just looking for min, and this has to be it because this is the only negative number. It's definitely smaller than the other 3 positive numbers. So I don't really have to try to rack my brain to ballpark these. I just know that this is going to be my min. So this is my min value. It happens here. I like to give both of those bits of information because sometimes they ask for one or the other. But in this case, they ask for what the actual min is, not necessarily where it happens, although they can ask for both. So this is the min. It happens here. And give yourself a third point if you identified that number, but only give yourself that point if you did the entire candidates test. Okay? Number D. Okay. Now we've got a brand new function g. And fun fact, g of pi over 2 equals 0, and the graph of g prime is given below. So find the value of the limit as we approach pi over 2 of f over g and justify your answer. Now, if I attempt to take the limit as we approach pi over 2, I'm going to get 0 over 0. Now, you may have done that in your head and realized you're supposed to apply L'Hopital's rule, but it's important that you explicitly show that because this is the proof that L'Hopital's rule applies. So I want to say if you don't have this, you might max out at 1 point or maybe no points. I'd have to look at the rubric again. But if L'Hopital's rule applies to a limit, you have to show why it applies. Show that the limit that you're trying to take gives you one of your indeterminate forms, either 0 over 0 or infinity over infinity. Just show that you get that. Even if you can do it in your head and you know that it gives you an indeterminate form, you got to explicitly show the grader that this is why you're going to be applying L'Hopital's rule. So 1 point for explicitly showing why L'Hopital's rule applies. And if you are using it, it doesn't hurt to explicitly state that this is what you're doing. But then another point for this is the actual use of L'Hopital's. I'm going to take the same limit, a different function, f prime over g prime. So you get 1 point for explicitly showing the new limit that you're taking, the limit as you approach pi over 2 of f prime over g prime. Now f prime comes from the old f prime. I don't need to rewrite it or anything. I'm just going to plug pi over 2 into this, and I'll get e to the pi over 2 times 0 minus 1 all over g prime of pi over 2. Now that comes from the g prime graph right here. G prime of pi over 2, right there, is 2. So That's where this came from. This came from running numbers in the actual f prime function. This came from the graph. And then I just clean it up and you have your answer. So part D has 3 points. 1 for showing why you're allowed to use L'Hopital's rule. Another point for actually using L'Hopital's rule and showing the new limit that you're going to be taking. And a third point for the actual value. So that is all 9 points. Please go ahead, use this video to create your work, and then just leave a comment on your assignment in Google Classroom so I know how everybody's doing. Okay? If you have any follow-up questions, shoot them my way. You guys have a good day.